starting again. We are going to measure the height of this again. To measure the height of this, we are going to construct a triangle again. We are going to construct a triangle. So we are going to have a string from there to here and another one from there. So can two boys come and help me to construct the two triangles? So we're going to have a little cow again. That one is short. Come. Come. Somebody say that I'm anti. I should go straight. Come on, guys. I'm part of the lesson. And after never nana. Right. Right. Where's that thing that protects? Yeah, you can put the other one on top. Right. So sleeping motor measure the angle. I get this one. So you measure that angle. Yeah, alright, it's fine. You don't have to measure that one. You don't have to measure that. Right. We have our two triangles. I guess. Okay. Then I'm going to use this one. Okay. Okay. Okay, we have our triangle again. Right, we know that this triangle, these two triangles from the side. These two triangles. We have another one here. Somebody come and help, please. There's another spoon. Let's see the move. Ito malaki. Ito malaki. Can you see our 3D? Right, this is how you must always view your 3D from a question page. Again, right. If they tell you about the horizontal plane, this is the horizontal plane, this one. Right, and then we know that this triangle. So where are those things? Right. So someone should name our triangle, I guess. So this one will be our angle A, the one on top, I guess. And then where's B? Where's angle B? So angle A, no angle A, I guess. So this one is B. It's fine. Right. And then this one will be angle C. This is your angle C. This is angle C, and then angle D. Angle D. So we have all the angles, I guess. Right, we have our angle A, B, C, D. E, where's E? We can't have E. We have only 3 angles, I guess. It's a 3D. Right, that's how I say. Or this is our horizontal plane. Right, and then, so it's important as well for us to see that this angle, this one, the angle formed by the triangle and the horizontal plane and the height is always equal to 90 degrees. Okay? So this one represents my 90 degrees. Right. So I'm going to move here so we can see our angle B. So what our triangle A, B, C is a right angle triangle. Okay? And then triangle A, B, D is a right angle triangle as well. Right. So now we want to measure the height of AB. Right. So to measure the height of AB, we've constructed triangle ACD. Again, and then triangle ABCD with ABCD right angle triangle and ABD right angle triangle. Right. So we know that if we can be able to find the length of CA and the length of DA, again, right, we'll be able to find and then find this angle as well and the other angle. So we can be able to find the height using trigonometric ratios, which is sine, tan, and cos. Right. So now, so which rule can we use since we have our protractor? Where's the protractor? Which rule can we use to measure this triangle ACD? Triangle ACD. Can we find the length of triangle ACD or anything? What can we do? Do you have anything? We only have the protractor. We don't have the tape, measuring tape. I guess. So how are we going to measure? How are we going to find the length of this triangle? Maybe length CA and length GA. Which rule can we use? Yeah? Which rule can we use? Huh? We don't have sides, I guess. Why we don't have sides? We don't have sides because we don't have the measuring tape, I guess. But we only have protractor. Which rule can we use to measure sides? If we only have angles. Which rule? Sine rule. But sine rule you only have 2 sides. You only have, it's either you use side A and side B. Right. So therefore we can't use sine rule. We can't use sine rule because sine rule we should have at least one angle again and 2 sides. Like it's saying the sine rule use it when you have 5 sides angle. You see? Or you may have angle side for sine rule. Again, if you are looking for the side. See? Then let's look at the cosine rule. The cosine rule, use it when you have side angle side. Right. Or when you have side. Right. So which rule can we use? We don't have a tape measure. Which rule can we use? Is there a rule that we can use? Hmm?
We use trigonometric ratios like that.
To measure which side? So we can use, if we have only angles, we can't use any rule. We only have angles. Huh? We can't use any rule. We can use thick ratios to find a side. But we must have at least one side. You see? So because now, can we be able to find the angles of this triangle? This one. Triangle ACD. How can we find the side of triangle ACD? Huh? Right, we can measure, we can use the protractor to find the angles of triangle ACD. Again, right, remember I told you that if you have triangle ACD, you can't use triangle ACD to measure the angles of the angle C of triangle ACB. Again, because this angle, okay, can I draw the triangle here? This is the triangle, I guess. And then this is your height. This is your angles, right? So if you look at this triangle, when you draw it in the chalkboard, right, you may assume that this is angle, this is your angle A, I get. This is your angle C, this is your angle D, and then this is your B. I get. Right, by looking at this triangle, you may assume that if you know angle C, can I call this one C1 and then this one C2? Right, if you know C1 and C2, you may assume that angle ACD is equals to angle C1 plus C2. Is that so? ACD. Is this correct? Huh? Why? Why is it not correct? They are not on the same triangle. Again, if you check angle ACD, it's not on the same triangle with angle C1 and C2. Again, the same applies to C1 and C2. They are different triangles. Again, but if you look at it, looks like C1 and C2 are part of angle ACD. C1 is which angle? C1 is which angle? C1 is this one, again, and then C2 is this one. Huh? Like, oh, this one is C1, this one is C2. So you can't say this angle C, angle ACD is equals to C1 plus C2. Can you see? Because these are not the same triangle. Right, now, so we want to measure the height of this triangle. Again, right, we've seen, for us to measure the side of this triangle, right, what we can find now, using the protractor, we can find the angles. Again, which angles can we find? We can find this one. We can find this one. The angle A. Angle A what? C. Angle ACD. So if I can be able to find angle AC. Alright, for now, let's find, can we find angle A, angle C, A, D? If we know angle A, C, where's angle ACD? Or angle CAD, that one on top, I get. So if we know angle ACD and then angle CDA, so we'll be able to calculate angle ACD using angles of a triangle. I get. Right, so can we measure this one? So how are you going to measure this angle? Which way? Starting from 0, again. Again, this is 0. Yeah. Right. So 0. Yes. Which way must I put it? This way? This way, yeah. This way? Yeah. Starting from where? I must start from 0 again. So to measure this angle, I must put it like this again. So it's going to be 0, 10, 20, 30, 40, 50, 60, 70, 80. Right. Probably 80 because this line was 0. So this angle is 70 degrees. It's angle what? C. Angle, not angle C. No, we can't call it C1. It's angle ACD. Angle ACD equals to 70 degrees again. So we can as well measure angle D. Angle D. Angle CDA. Angle CDA equals to 69. Angle CDA. I think you must come and measure these angles. I can't do everything for you. Somebody come and measure. Come. Right. And then you must come and check how we measure these angles. Angle CDA equals to 0 must be here. So equals to 60 what? This is 60. So it's equals to this angle CDA equals to 66 degrees again. Right, now we want to measure angle CAD, the one on top again. So how do you measure the one on top? We are going to use angles of a triangle. Therefore angle CDA equals to 180 minus 60 or 66 plus 70, which is what? Equals to 44 degrees. Right. So what do we have now? We have three angles again of a triangle. We have three angles of triangle. The one on top again. Right. Now, so can we use the three angles to find the side? To find the side. We must have at least one side. So how are we going to find at least one side? We can measure. Right, since we don't have a tape, let's use our meter stick to measure the side. Right. Let's use our meter stick. Maybe what? Maybe we can measure from there. To where? Come and help. To find this thing, we are going to use this thing because so you to know shooter mic, okay. Right. So we are going to use this step ladder because this step ladder we are going to make side CD using the step ladder because we know that the side CD equals to 2.8 meters. Right. Therefore, what do we know? We know the three angles of triangle ACD and the length of CD. Right. So which trig ratio can we use to find the length? The sine rule. You can use the sine rule. Yes. Right. So how are you going to use the sine rule? Because we are looking for what? We want to find which one are we want to calculate? We want to calculate AC again. Yes. So we are looking for AC. Therefore, we are going to have sine sine or AC
over side.
AC
Divided by side.
AC over
Side.
AC. Where is AC? AC over sine D. Over sine D equals to
CD over sine A.
CD over
Sine A.
sine A. Again. So the reason we put AC on top is because we are looking for AC again. Yes. So we can multiply by the denominator. So can we substitute? Yes. Therefore, AC equals to, so what is CD? Do we know CD? What is CD? 2.8 divided by sine A?
Sine 44.
Sine 44 times
Sine 66.
sine 66. So you can punch a calculator. So here's commas degrees. AC equals to
3.7 meters.
3.7 meters. Right. So now, what do we know?
We have the AC.
We know side AC. Again.
Yes.
Right. Therefore, we can use our trig ratio to find AB again.
Yes.
But to find AB, we first need to find at least one angle again in this triangle. You know that this is 90 degrees again. Therefore, we can use our trig ratios, right? So, which one can we measure? Right, come and measure is angle ACB. Come. But our zero must be straight at the corner. So here's how you're going to make it. Let's calculate 0. It's 45. Right. That's what I can see. Right. Can you see that is 45 degrees? Yes. Right. You must make sure your protectors from the string again. Then you count in from 0. So it's equals to 45. What angle is this? Angle ACB. It's angle ACB. ACB. Yeah? Yes. Angle ACB equals to 45 degrees again. Yes. Right. So since we know we have at least one angle again and a side again, therefore we can use our trig ratios to calculate height AB. Again, right. So we are going to look which trig ratio are we going to use? Yeah? Y cos. Yeah? Y cos. You must know your trig ratio again. You must know your SOHCAHTOA. So we have the hypotenuse again. So since we have the hypotenuse, therefore we can use tan. Again. Right. Therefore it's either we can use cos or sine. Again. So for cos we must have what? Opposite, adjacent over hypotenuse. So we don't know the adjacent. Again, we know the opposite. Therefore, we are going to use sine. Again. So what are our height? Another sine what?
Sine 45.
Sine 45. Which is angle what? It's angle ACB. Again. Sine 45 equals to, there's no space, I'll write on top. Sine 45 equals to AB over AC. Again. Right. Therefore, AB equals to sine 45 times what's AC? 3,7. So is equals to 2,6 meters. Right. So now we've calculated our height. Again. Right. Okay. So what else can we calculate? Can you create any question from this 3D? That you can check from the textbooks and then look for any other question relating to this one. Like this one. Right. Do you have your books with you? Page 127. You have page 127. Let's look at page 127. It was number 4. I gave it to you as a classwork or homework. Number 4. So it's the same question as this one. But then you are given this length as 200 meters. And then, do you have it with exercise 3? Right, so let's compare that question and this question. Can we compare the questions? Right. The question says, in the diagram, can you see the question? Do you see number 4? Yeah. Right. Can you change number 4 to this diagram? This diagram number 4, can we make it this diagram? Therefore, this one is going to be our angle A, again. And then our angle C will be the angle at the top, right? And then C, B will be there, again. Right, so can we answer number 4 looking at this diagram? Can we change this diagram and then make it this diagram? Right, let's do number 4. Let's do number 4. Let's do number 4. So here, where's your angle of elevation? Yes? Where's your angle of elevation here? Yeah? This one is the angle of elevation. Right. And then where's your angle of depression? All right. Are you doing number 4? Yes. Right. Right, I want you to do the whole exercise. Look at any diagram that is similar to this one. Again, change the angles and then answer the question. I want a question.
Like a side, angle, then side, then we can find this side here. One year, I need to be a measure and
How will I do get angle CDA?
64, yeah. 64, yeah. Good, this one is actually 64.
Calculate the height of the balloon above the ground if angle A.
Just go there.
Arm and voltage stands 200 meters apart at A and B. Then we'll start
Just go there. Like it.
ACD 64.
Ask questions. Is there any question? Right, are we happy now with the diagram? Huh? It's fine, you may go back. If you're done with the diagram, give us other space so they can come and discuss this. I want you to go to page 128 again. Right, on page 128 we are going to utilize our compound and double angles to answer these questions again. So you look at the example on page 128, so where they utilize the compound and double angles again, right, and special angles. So you do for me exercise 4 exercise 4, number 1 and number 3. So you must use this diagram as well. Visualize the diagram. So you change the diagram that they gave you to this diagram again, or you change this one to this one, right? So now this, we check the diagram. So this on exercise 4, the diagram, your angle A is going to be here. So the angle at the top is going to be angle D. So you have theta, and then side AC, this side AC. So here is CB. I guess it's going to be side BD. Again, since the two sides are equal, again, so in this triangle, therefore, this angle is going to be equals to this angle, again, right? So that's why you'll be using your double angles, again, and your compound angle formula. So look at example number, look at that example, again, on page 128, do for me number 1 and 3 as a classwork, again, and then number 5, 6, 7 as a homework, right? Thank you very much. So we can clear our position.